Okay, what you're about ready to start is a pretty tough algebra worksheet going over the geometric concepts that we've started. My goal here right now is to give you some pointers to get you started on each problem, and then it'll be your job to finish off the problems and give me your correct answers. Alright, number one, the diagonals of a rhombus are D1 and D2. Find the expression for the area of a rhombus. Look up an area formula, you should be able to write it down. 1/2 of D1 times D2. It gives us D1 and it gives us D2. We're going to take those values, we're going to plug them in, and I get 1/2 of 2x minus 6 and 4x plus 3. It says find an expression, so I expect this answer down here, I expect that answer to have an x in it. So this now becomes a process of foiling, distributing the 1/2 through, and getting an expression for the area of the rhombus. Alright, number two, find the other base of the trapezoid whose area is given, whose height is 20, and one base is 3 inches. So we write down the area of a trapezoid formula. Do that now if you can remember it. And hopefully you're writing that down. This is the area, it gets plugged in. This is the height, it gets plugged in. One base is 3, it gets plugged in. You can call the other base, you can leave it be 2, or you could call it x, and your whole job is going to be to solve it out for that x. That'll be your answer. Find the other base. When you go through that algebra process, you should be able to write your other base right down there. Okay, problem 3, find the area of a parallelogram. One thing I noticed right now for the area of the parallelogram is no height is given. So I can't use this slanty part for the height. I'm going to have to dot in the height right here. I could also do it over on this side. I'm going to come over here because I can find this angle real easy. These two angles add up to 180. If that's 155, this has got to be 25. I can find the height really easy by using SOHCAHTOA. After I find the height, I can use the area of a parallelogram formula. Plug this in, plug whatever I get for my height in from SOHCAHTOA, and it will be real easy for us to find the area. Okay, problem 4, another find the area problem. And I notice I have no height given again. I do have base 1 and I have base 2. You should go on to your notes right now and find the area of a trapezoid formula and write it down. You're going to plug these numbers in, and you're also going to plug in the height. Now in this problem, I could use 30, 60, 90 if I wanted, because I noticed a 60-degree angle there, 90, it's got to be 30 up there. But because this is a decimal, I would probably, again, go SOHCAHTOA to find how tall it is. And I'm using all of these numbers over here on that formula to come up with the area of the trapezoid. Okay, this wants us to find x, and x happens to be an angle. One way I know how to find angles is I can use an inverse trig function, SOHCAHTOA, sine, cosine, tangent to the -1 to find that. So if I knew the height, I think I can find this little chunk pretty easy. 12 isosceles, and that's 20. So it would go 4, 12, and 4 would get me a total of 20. That was 12 and 4 and 4. Okay, that's 20 and the top is 12. So I have that little piece. Now really what I got to do is I got to go in and find the height. I'm going to use the area of a trapezoid formula. I'm going to plug numbers in. Area is 112. Base 1 is 12, base 2 is 20. 12 and 20. And I don't know the height, so I'm going to leave it in h. What you need to do is you need to find the height. I'm going to take that height and I'm going to write it in this spot for the height. After I find that height, I can go in there and I can either use sine to the -1, cosine to the -1, or tangent to the -1 to come up with that angle measure. I'm going to let you pick out the right one. Problem 6 is a drawing problem. You can draw it down below. I'd like you to try problem 6 without my help. See if you can read the directions and solve. Okay, it says find each measurement on the next side of the worksheet. It says the perimeter of the rectangle is what it wants you to find. It gives you an expression for area. It tells us rectangle, so I know that's there. I know that's a y. It wants us to find the perimeter. I'm gonna use this formula. Area of a rectangle, base times height. Area is 2xy. My base, I don't know. I'm gonna leave it a b. My height, I know, is y. Solving for b very easily, I can divide both sides by y, and I get an expression for the b value. That expression for b put right there, which would also be the same as this one, and you can add those four things up and find an expression for the perimeter. Remember, perimeter always stands for add all sides. All right, what's an expression for the area of a square? Two ways I can do this. We can use the formula area is equal to sides squared, or we can use the formula area is equal to base times height. It's a square, and that's a minus b. This would also be a minus b. So I can do either a minus b squared, or I can do a minus b times a minus b. Well, it turns out that this actually turns into that. So if you went through that, if you started there, you should turn it into that. And then our wonderful acronym is what comes next for your final answer.
Outside, inside.
Okay, they want us to find height of a parallelogram given an area and given a base. This is one we did yesterday in our example problems. Area of the parallelogram is base times height. So plug and chug. Area, 96, 96. X cubed equals the base, 8x times the height, which I don't know, h. It's an algebra problem, get the h by itself. I'll let you try that. They want us to find base 1, and they want us to find area. We'll do this one first here. Base 1, they want us to find this value. They gave us some algebraic values, and they gave us an area. It's a trapezoid. Area is 1/2 base 1 plus base 2 times the height. 4x squared goes in for area. 1/2. Base 1 is 3x. Actually, base 1 will be 1. Base 2 is 3x. And the height is 2x. Okay, a little bit harder to solve here. I'm going to do some algebra here to help you get there. We're trying to find base 1. Let's see if I can get you partway there. So what I would do right now to make this an easier problem, I don't like that half, so I would actually combine these. 1/2 times 2x. Well, 1/2 times 2 is basically 1. In essence, that goes away. It becomes 4x squared equals, those two make x, and then I'm left with b1 plus 3x. Okay? Next thing I would do is I would distribute the x through, and I would attempt to solve it out for b. It's a little bit tricky algebra. I want to see if you can do it from here. Last problem, find the area of a triangle, and this time it's numerical. I have a bunch of numbers. The problem is this is a triangle whose base has been rotated, and that would be the base. I write down the area of the triangle, 1/2 BH, and I don't have that b. I have the half, I have the height at 24. I need to find the base. Here's what you're going to do. You're going to do the Pythagorean theorem with this triangle, and then you're going to find that little part with that Pythagorean theorem. And then you're going to do the Pythagorean theorem with this triangle with the x in it, and then you're going to find that value right there. And once you find those two values, you can add up that value, and you can add up that value, and that's what will go in for the base of the triangle. That will help you find the area. Okay, problem 6, find the area of the trapezoid. I have a bunch of variables. I have a's, I have c's. You know what? There could be very likely an expression here with like a's and b's and c's in it for my final answer. Area of the trapezoid again, 1/2 b1 plus b2 times the height. b1, plug it in. b2, plug it in. Height, plug it in. Okay, you're definitely going to have some expression. You're going to have some parentheses. Once you plug those in and combine them down, you're going to end up with a binomial. You're going to end up with 2 terms there. That h value is a binomial. You'll end up with 2 terms, and you have half out in front. Well, we've seen this before. Do that first. take the half through the parentheses second. I'll let you give that a shot. Okay, they want us to find the perimeter of this kite as a decimal. So I'm going to find the perimeter of a kite. I'm looking for all the sides. Nice part about a kite, those two are the same, that's the same. Looks to me like I'm going to have some Pythagorean theorem problems. I'm probably going to have to use the area in there somewhere. This one honestly is a really tough problem. So first of all, let's find this, let's just call it A. Let's find the A value. And I can do that with the Pythagorean theorem. I got a right angle in the middle. I can go 4.8 squared, which is that distance, plus 9.0 squared will equal A squared. And that will give me that, which I'll have two A values. So I can add those two pieces up to help me find the perimeter. The hard part is this one right here. How do I find that? And in order to do that, I have to first go and find this total diagonal. Okay? Area of a kite, 1/2 d1 d2. Area is given at 49.92. 1/2 of the first diagonal, which is 4.8 plus 4.8, 9.6, times diagonal 2, d2. Now you're going to get a value for d2 by doing this math. You'll get something for d2. That'll be the whole distance there from tip to tip, which means this chunk is whatever diagonal 2, the whole distance is, minus 9.0. Probably shouldn't be very much. I'm not looking at a very big chunk right there. That chunk right there will help me get what we'll call value B. I'll take this, and I'll take this, and I'll take B, and I'll do the Pythagorean theorem to find this chunk. After you find that chunk, you can add all of them up to get an expression for the perimeter. Pretty tough problem. Let's call that bonus.
Bonus!
Word. What up? Alright, number 8, last one. It wants us to find the area of a rhombus. It gives us D1, it gives us D2, it gives us parentheses. I do have different variables, which is a little bit concerning, but area of a rhombus, area is 1/2 of D1, D2. Diagonal 1, it gives me x plus 4. Diagonal 2, it gives me 2y minus 4. And I forgot my half, so I'm going to go back and put it in. Again, FOIL that out. You'll have an x and a y. By the way, x times 2y is simply 2xy. You can finish the FOIL. After you're done with the FOIL and combining terms, you can take the half through the parentheses for your final answer for the area of the rhombus.
Oh, yeah.
Good luck.